Thank you, Jean-Chaldon. Good morning, ladies and gentlemen. Thank you for inviting me back to Beijing, and thank you for allowing me to speak in my language in your country. Maybe someday I will learn to speak your language better than I do now. Thank you to the translators for doing so. The ceremony we just had was really a cementing, again, of the partnership that ONF and BII have to run the OSPC, the Open SDN Promotion Center. This is really a bridge between China and ONF and the rest of our worldwide activities to make sure that we understand what is happening in China and that the many things that we are involved in are also known inside China. There is really no country in the world that is doing more in SDN now than China. And so it's really a pleasure for me to come here and celebrate in both formal and informal ways the work we are doing together. My talk this morning is entitled, as you see, one that really salutes the name of this conference, the SDNFV Technology Conference. So what I will discuss with you is why I'm using the single term SDNFV, what convergence has arrived, and I'll talk a little bit technically about SDN and NFV, just for a moment about the linguistic aspects here, and also the organizational aspects that not only have motivated this position, but that will continue to drive it. I am always happy to show the same slide year after year after year, which is that the value proposition of what I'm now calling SDNFV has not changed, and I'm glad it has not changed. It's used by network operators either to make money if the network is their line of business, or to save money if it uses them in some other way of running their business. And you can see the examples here. We heard some actual use cases this morning. We saw the TerraStream network at Deutsche Telekom, NovoNet at China Mobile, and CubeNet at China Unicom. And yesterday I visited China Telecom and was able to see what they are doing in bringing these technologies not only together, but also to market. Now, you've probably seen this architectural diagram of SDN for at least the number of years I have been coming to China in this role. And we have these different planes. I will admit we don't do very well with the management plane. It's kind of embedded in what we do. We will probably make it more explicit as we go forward. But you can see the user plane, control plane, application plane with well-defined abstractions and interfaces between them. The southbound interface looking down from the control plane, and the northbound interfaces looking up or northbound from the control plane to the application plane. Now, when we got started at this 5 years ago, we were all about the southbound interface. And we had some southbound interface wars. Is it OpenFlow or something else? Those have largely evaded. There are a variety of appropriate southbound interfaces in SDN. OpenFlow is being embedded more and more in products, and it's being sold without being advertised. Oh yes, OpenFlow is in our product, but we're not selling OpenFlow. We're selling the capability and the solution that it provides. So these were the big wars of the first couple of years. We then decided we'll have some other wars. So we've had the controller wars for a couple of years. And they're finally abating. They are dying down. We have a variety of open source controllers. We have quite a few proprietary controllers, but more and more the proprietary controllers are being built around core open source centers. I think one of the factors that is going to bring an end to the controller wars is the wise governance and oversight of the Linux Foundation, which now oversees two of the main warring parties. Well, when these wars are about to go away, what's our next war? We always need to have something that we battle over. So maybe we're going into the orchestrator wars. I'll talk a little bit about that. In my personal opinion, we have a lot of activity going on in controllers because we can do so now. We have most of the plumbing of the lower layers fairly well established. And the orchestrators have to do with how you compose these various components, both virtual and real, to create actual services. And services mean making money or saving money. Services touch the business. And that's where SDN and NFV are important in business. So what's actually happening here, and what's happening with SDN and NFV together to enable us to at least have the orchestrator wars? You might be familiar with the term Venn diagram. I have two of them shown on the slide. They are actually named after a person, John Venn. Who would have thought? In 2012, at the launch of the TSDNFV Industry Specification Group, we had the Venn diagram shown on the top. Oh, SDN and NFV have a small amount of overlap, and with this whole thing of open innovation. But mostly they're independent, they're orthogonal, they can collaborate, but they don't depend on each other. 4 years later, we have a very different Venn diagram shown on the bottom. There's a high amount of overlap. Where we talk of one, we also have the other. And it's hard to distinguish them. I'm calling this now Open SDNFV. And it's so much easier to say SDNFV than it is SDN and NFV, or SDN/NFV, or some other clumsy linguistic term. Since we talk about them together so much, I'm just going to use the term SDNFV. So back to the architectural diagram. It has to make sense, not just linguistically, but technically and in business, for us to merge the terms so often. And it turns out that indeed, it's not hard to do so. I think the best efforts that the TSDNFV ISG made in its first 2 years was to create the architectural framework in a way that positioned SDN and NFV so that NFV could take advantage of SDN. And you see that here. And then in particular, the orchestration that bridges these to enable you to compose services based on virtual and real network features. And this is where we find ourselves today. It's a hot topic, and the reason it's a hot topic is because so much is riding on it and depending on it. So if you orchestrate things properly, SDNFV will provide you with all of the things that the operators really want. And I'm showing them here. Programmability of the network, that's what started us on this journey. Automation, which both enterprises and telecom service providers value and exploit for operational savings and for service agility. The elasticity and capacity to save resources, use them efficiently, and not just use them efficiently to make the most money out of the investment you have in them. Openness, of course, is what we have been advocating for in protocols, in architectures, and in interfaces. And we are making progress. We are trying our best to get the operators and the vendors to work cooperatively in open solutions to give operators the best of breed choice in building out their networks. So the abstractions we defined in SDN have been a model for the abstractions we find in NFV. And together, if you have the right abstractions, you can extract functional value from them. This is the Mano architecture from TSDNFV. but look at some of the functions and the efforts that have come out of them that have actually made real progress, turned into products, and turned into code. We have increasing work going on in common information models across the industry bodies. We have policy-based derivation of how the network is going to operate. We do the policy interpretation at these high levels, so the forwarding plane doesn't need that intelligence. You'll hear from David Ledrow shortly today on intent-based northbound APIs that allow the applications not to have to know the details of the underlying network as many do today. Service chaining for VNFs and NFV, network slicing for 5G. This is actually a challenge and an opportunity both. A lot of pieces need to come together for efficient network slicing, but we have the pieces to compose those. So some examples of how you can take NFV and do various things with SDN underneath to create orchestration frameworks. And you'll hear from Mark Cohn this morning about OpenO from the Linux Foundation. The formal launch is happening this month. And it really puts NFV management in a context of SDN. And what's exciting about this is that there is a huge amount of momentum already and promised investment. In fact, not just promised, committed investment, most of which is coming from China, as I've listed here, but not all. This is going to be a worldwide effort. It's in the Linux Foundation, and we think it's one of the most important open source projects and multi-industry collaborative efforts to appear in the last 3 years. OPNFV, the Open Platform for Network Functions Virtualization, also in the Linux Foundation, started out as a framework to marry OpenStack and OpenDaylight. It's since added ONOS as another controller. And it's really not trying to pick winners either in controllers or in orchestration systems, but give you a framework for building kind of a working model of how you as an independent service provider can construct your network operations in software and hardware from the widest choice of available components. Now, because orchestration is hot, a lot of people are getting involved, and new ideas are appearing. In fact, it's sometimes easier to write your own orchestrator than to study the ones that are out there and figure out whether they work in your environment or not. Among the prominent open source ones I've shown here, we also have open source Nano. This is a new project in Etsy, which has never really done open source projects before, just standards. We have Open Baton. I guess this orchestrator and conductor and orchestration and musical metaphor continues. From the Fraunhofer Institute in Berlin, this is a research institute, but they built a very interesting example of an orchestrator completely open source. You can go to openbaton.org and play with the code yourself. They're not intending to commercialize it, but it's intended really as a tool for rapid learning of what you can do and what you need to do to have a viable orchestrator framework. Open Lifecycle Service Orchestration from MEF is a way of sort of bridging what we do with carrier Ethernet and lifecycle service orchestration to achieve cross-domain, cross-network ability to compose an end-to-end service. So ONF's role in this is as an enabler, as it has been. We have been the champions of OpenSDN for now 271 weeks. That's how long it's been since our formal launch and since the day I joined. And we still have these three pillars of OpenSDN, open flow, and open source. But there's some interesting new work areas. We're always trying to solve the needs that are most pressing on the network operator community. Information modeling has proved to be a surprisingly important one, I mentioned earlier. The northbound interfaces are making rapid progress. We're working with the operators on how they can move to an SDN and NFV environment without sacrificing the investment they have in their current network installed base. Most recently, we've started an effort in cross-stratum orchestration, We'll be hearing more about that in the coming months, and I saw some really good discussions of it yesterday at China Telecom. We have these different strata of control and application and an orchestrator. How do we do this across different controller environments for application portability, and most importantly, across different operator domains? And much of this in the service of 5G. I was very glad to hear the speaker this morning say that 5G will not be successful without SDNFV enabling it. I've been saying this for quite a while and asking people, how does SDN or NFV, how does that enable 5G? And I get many different answers and a lot of confused facial expressions. So then I ask a different question. Don't tell me now how it's going to be done. Can you imagine that? Can you imagine 5G if we did not have SDNFV? And nobody can imagine 5G without SDNFV. OpenFlow continues to get better and better. It is the forwarding claim abstraction, it is the model, and it is the protocol. We've had tremendous progress recently on the optical transport SDN. Wireless transport is coming along also very quickly. And we continue to work on ease of deployment in hardware. And of course, for the last couple of years, we've been working to augment our standards and specifications and interface work with open source software as a way of getting it into your hands quickly for you to learn from and build upon. I stole this chart from one of your upcoming speakers, Mark Cohn, because what I think it represents is how we in the industry have a new model of bringing the industry together to create new solutions and get them to market quickly. It's almost as though we have a DevOps model for standards. We combine standards of open source, we get feedback from implementation experience into our specifications, we create open source reference platforms and implementations, all to speed the cycle of trial and error, trial and error, trial and error, and ultimately successful deployment. We believe in partnerships that have you sitting on the same side of the table, not opposite sides of the table, giving things back and forth. The transom is that opening over the top of doors that opened when you didn't want to unlock the door. This old cartoon shows someone throwing something over the transom. We don't throw things over the transom. We sit down with actual collaborative projects. You can see the many organizations that we are actively collaborating with. We bring the expertise and the unifying architectural ideas of SDNFV to these many partners so that they can work without overlaps and with some consistent intellectual framework underlying the work that they do. We live in a broad community. We try to put an umbrella of SDNFV over the community members that we collaborate with, many of whom are very active here in China, as you can see in the alliances that are strongest here, the open source projects, the international standards and consortia organizations, and even some of the new very specific ventures for 5G, for example. We feel this as a commitment and an obligation for ONF, that we owe it to the industry to try to help all of them and help them help each other. We have made a lot of progress in 271 weeks. But next week, after 272 weeks, we will hopefully have more progress. However, a lot of work remains. The operators still have many challenges of deploying this. We don't have all the features in SDNFV that they need to run profitable businesses. We have so much work to do in management, and not just of the new parts, but integrating with the existing management frameworks. Operationalizing says, well, this is well and good, but how do I get it into my processes? How do I get the skills in my people? How do I make it work in my organization? And then the last bullet is really important. The world today is not a greenfield network where you start from scratch and build something new and you can use the latest and greatest technology. It's a brownfield world. We have to start from there, bring in the new components without wrecking the old components. Our mission has not changed, and it will not change. We are here to accelerate the successful commercial adoption and deployment of Open SDNFV. This conference is a means to that end. I enjoy coming every year. We have 2 full days of excellent programming. I look forward to meeting many of you throughout the 2 days and to seeing you in the months and years ahead. Thank you very much.